Okay, so we just completed numbers 1 through 4, and you should have completed or almost completed with number 12 in this massive review packet that is online. Most of you got number 1 correct. That's A. Don't forget that you have to combine only like terms. The X's have to go together and the numbers have to go together. Number 2 got a little more difficult. What was the tricky part about number 2?
What you should add. No, that wasn't difficult.
Minus 9.
Can someone grab me that pencil?
The tricky part was it had a minus, a minus. Well, they're dead. There we go.
Luke, no.
There's an X right next to there. Oh, wait, no, there isn't. Oh, that's what I was. Oh, Leah.
Well, you can wear my shirt.
Okay, Bethel, please turn around and stop talking. We have to add the X's together, but we have a minus. When you subtract a negative, Nathan, you need to add it, right?
Yeah.
Okay, so this would be 5.1x plus 4.3 minus negative 7. You're going to add those together, so it's going to be 11.3.
Okay, that's really dumb.
Ariam,
Yeah.
we don't need to know all of the thoughts that come through your head.
Okay.
I just think any is a good choice.
Yeah,
I want to know some of the thoughts that go through your head, but just not right now. Okay, so number 3, negative 9x plus 3, in parentheses, minus 5x minus 2. A negative x minus 5x. Negative minus a positive is going to give us negative 14x. 3 minus negative 2 is going to be plus 5. Is coming back to you? Totally. Okay. Those of you who were having a hard time with number 4, do you see why the correct answer is B?
Yeah.
Yes.
Okay. And number 12, the correct answer is D. Good job. D.
Easy, man.
Okay.
Luke, it's fine.
Okay. So here's how this week is going to go. We are having a math test on Friday.
Master quiz.
Test.
Oh, great.
Test. Real test.
Okay.
Test that back, please.
Mrs. Cummings, can Ben sit like right next to me so that I can cheat? I'm sorry.
Whole squad laughing, literally doing laughter. Hashtag shook.
Looking for
Nine
a
blocker.
whole squad laughing.
Whole squad is flying right now.
Whole squad guys laughing.
Pass the minute over. Okay. Online for you distance learners, and here is a wrap-up. Unit 4 is linear equations and systems. You can use this sheet on your test. You will not get another one. If you lose it, you're out of luck. And it must be in your handwriting, so you just can't copy, have someone write it for you or anything like that. So put your name on this. Don't lose it. Luke, put your name on this. I will not be giving you another one.
Right, my name is Andrew.
So if we write out, we use a calculator on the test?
You may use the calculator on the test. You can write notes on this. You can use this on your test. So you can write notes on this. Things to help you remember. Here are the things that you need to know. You need to be able to graph an equation in the form y equals mx plus b.
So
If
what we
you-
just did.
What?
So what we just did like a couple days ago.
Uh-huh. Yes. Y equals mx plus b.
Yes, some people were, yes. Some people didn't.
This is your slope. It tells you how to move. Rise over.
Sorry.
The gentlemen have been much better about talking in class, but the ladies have picked up the slack, so to speak. Rise over run, and this is the y-intercept. It's the starting point. If you feel shaky about how to graph this, then you should probably write this down. This is where you start, and this is how you move. Okay. Know what a solution to a system of equations means. So if somebody is walking away from a parking lot and somebody's walking to a parking lot, the solution is where they meet, is where they're going to cross each other. If water is draining out of a sink and the sink next to it, water is going into it, at some point they're going to have the same amount of water. That's what the solution means. Okay. Check if an ordered pair is a solution. We haven't talked about this explicitly, but I'll be pointing it out in the next couple of days to make sure you know. You guys have been doing it. You put the number in to see if they equal each other. Find the solution to a system of equations on a graph. So you graph it like this, and then you see where they intersect, and that is the solution. Find the solution to a system of equation algebraically, so you set them equal to each other, which most of you have been doing in class. You've been finding that to be the easiest way. Determine the number of solutions, 1, none, or infinite. Do you remember how to do that?
Totally.
Yeah.
Shaky, no.
Okay. We need to be able to do that for just an equation or for a system of equations. And then find the solution to an equation on those mobile hangers, like we did way at the beginning. If I tell you like the triangle is 2 and the circle is 4, you tell me what the square is. Okay? Those are all skills you'll need on the test. We are going to look really quick at lesson 12 with the cups that you guys should have done over the weekend. And then we also, this is all of the rest of the unit before the test.
Great.
Okay? What? So let's go ahead and look. What did you guys discover about the cups?
There's a
It
lot.
was hard. Okay. What about the cups and your packet?
Confusing.
Confusing?
Essentially the same thing.
Okay.
There's 4.
What pages is those?
We're going to go over.
You got like 6
the one
packets.
from last week, 12.1.
Oh,
Okay, so go ahead and get out your 12. Your packet was 12.
I don't need that one.
You didn't do it at home?
No, there's only one computer and two seconds that I use it as well.
I don't know if I have any more. I don't know if I have any copies.
This is like 10 pages. Oh, it's like no. Okay.
How big is that? I think it looks like
I've tried to hold on to this.
But you looked at it online. I tried to a little bit.
Wait, we're gonna do the whole thing? We have to finish this whole thing before the test. We had like 6 packets earlier.
She just wants LOL.
Logan, while you were gone, we had like 5 more packets.
Pretty much a packet every day.
Yep.
Did you print out a packet for you? Well, did you do unit 4 lesson 12?
The online one?
Yeah.
And it has these little boxes?
my leg.
I didn't. I did something like that.
Okay,
No,
awesome.
Logan, this.
Okay, class, class, class.
I did a packet. I did a packet.
Okay, so you should have, let me get your attention, please. On page number 2,
What?
on page number 2 in the packet,
What?
the
Oh,
packet 12, sorry. Unit 4, lesson 12. The one from Friday. That was super close, I'm sorry, guys. No, the one from Friday. At the top of it, it says Unit 4, lesson 12. Was talking about milkshakes. How fast you can drink a milkshake.
Like Hans and Lynn.
Hans and Lynn. Okay.
Wait, what number is it?
Who says this? Oh, those are yours. Okay.
No, but what number?
We're looking at page 2. Give me a thumbs up if on page 2 you have equations drawn.
Yeah, we just did the partner.
This is the one you did in class. Okay, great. So the one you're really looking for then is number 3. Okay, so in the same packet, Unit 4, Lesson 12, go to page 4.
That's kind of, I don't really know how to do this.
Okay.
I mean, sort of.
Give me a thumbs up if you got the graph for page 4 figured out, and give me a thumbs down if you need help with that.
I don't know if I did it right.
Okay.
I didn't number it off. I thought
Okay. Let's get this pulled up. Okay. You don't even have it out. Never happened. Actually, maybe. Well, when? Okay, we are looking at
Oh, I
what
know
people
I
should have done for homework, which is 12 point, which is the page number 4, 12.3.
What color is the
Give me 1 second, I'm gonna pull it up. I'm tired of saying it over and over again because people are talking. You know when you're gonna listen. You were listening when I said it.
that's a great match.
Okay. Okay, 12.3 is stacking cups. It says a stack of small cups of a height h in centimeters has the equation of h equals 1.5 n plus 6. A stack of large cups has a height h in centimeters of h equals 1.5 n plus 9. Okay, thinking back to the cups, what does this 1.5 represent? When we're talking about the cups.
I do not have the sheet.
I just gave it to you.
This right here?
Yes.
Yes.
Okay.
Look, Canadian store.
It's not filled out.
Exactly.
Okay. So what does that 1.5 represent when we're thinking about cups that are being stacked up and down?
How high each cup is.
No, how high, like, the table they're on.
Yeah. It doesn't
The
go down all
how-
the way.
The stack, how high the stack?
How high the cup is.
No, how tall the cup is.
The cup is the 6 and the 9.
Oh.
The rim.
Yeah, the cup is, 1.5 is the rim.
Oh.
Because when you stack the one cup onto the next one, it goes up just 1.5 centimeters each time, because that's the only part that is stacking. Yeah? Okay, so we have these two equations we're going to graph. What do you notice about the two equations?
They're parallel.
They're parallel.
They're parallel.
Somebody tell me why Jameson is saying they're parallel.
Three.
They start at 6 to
They'll
9.
never intersect.
They will never intersect. So what does that mean about the two cups?
They'll never meet at.
Never taught. Never.
The two stacks are never going to be the same height, right?
Yeah.
Okay. So we're going to go, let's label these. We'll go by halves. I'm going to go by halves
No.
because I can. And these we're going to go by cups. No, this is also
2 cups. 2 cups. 2, 4, 6, 8, 10. Update.
2, 3, 4, 5, 6, 7, 8, 9.
Very small.
Height in centimeters. And this is going to be the number of cups. 1, 2, 3, 4.
What?
Oh my gosh.
6, 9, 7.
I wonder if something is wrong.
I feel like our class just got.
sheer
Yes, Jupiter.
Yes, Jameson.
Could you go, like, the one that starts at 9 is going to be, like super small.
Start at like 5.
No, just go 2, 4, 6, 8, 10, 12.
That's already.
Start by 5, then you have to go by 5.
Yeah, just do 2.
Because then you'll have more space to like add more. What?
Whatever.
Because like
Whatever
the line that's
is-
the bottom line's gonna be like.
I said that I did this set this up wrong, didn't I?
Yeah.
Yeah.
Yes, you did. Weren't you supposed
Hold on one
Yes.
second. No, because that has to be the Y.
No, just like this. Just like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And
She's not watching this
then it goes like the 9 would be like from here to here on that last one.
Okay, so you're saying go by twos.
Yeah, just go by 2 up. Not that way.
It's funny, look.
Cups can be the same. Yeah, that way. Good direction.
Okay.
How do you go from 18 to 26?
Oh, this is like
What do you mean? How do you go from
We went
18?
18, 26.
This class has been a disaster.
18 to 26.
Okay, so this top one is starting at 6 and it's going up 1
Like 5.
and a half. See, that's the problem with going by twos.
Yeah, you just go in between them. It's easy.
Easy.
Yeah, just go in between them. Wesley.
I thought you said it was up.
Just go up by 2.
I did that too. It looks stupid.
No, I need to go up 1 and a half. Oh, here.
Go up by 3.
3 and over 2.
Yep, precision.
Rar.
Precision.
But so we're here and 1, 2,
Oh.
That's not right.
6, 7, 8, 9. That's 3.
Oh, geez, that went way too steep. I went up.
1, 2, 3 over 2.
Why is it not erasing?
1, 2, 3 over 2. Okay, so here's the graph of that one. This next one starts at 9 and goes up the same amount. 1, 2, 3 over 2.
I got this. I was just overthinking.
Okay,
Yo, I actually got it.
so what are we supposed to? I need you to stop talking. Logan, turn around, please. The things we should be learning, the things we should be gathering from this information. 1, parallel lines have no solution. If they will never meet, they'll never have a solution, right? So if the slopes are the same, it means they're parallel and there's no solution, right?
That's why the second portion made no sense. Yeah. I did it so many times.
What do you expect will happen if, what can you tell me if the graphs were like this? There's the red cups, or the green cups, and here are the blue cups.
They stayed the same the whole time.
Okay?
Start at the exact
Every
same point.
solution.
Same point. So, okay, so all of these things are true. Let's take them slowly. Jameson, what were you saying?
They start at the same point.
Then we know they start at the same point. That means in the terms of cups, they're the same height, right? In the terms of walking from the parking lot, they're starting at the same distance from the parking lot. Okay? What did you say, Leah?
So they're gonna stay the same height the whole time.
They're going to stay the same height the whole time. So it doesn't matter how many cups. Each time you put a cup on, it's going to be the same. If we were talking about the walking to and away from the parking lot, what does that mean? With the example that we did a couple days ago, when one person is walking from a parking lot and another person is walking toward the parking lot,
They're constantly.
They're gonna cross each other.
they are going to cross each other. Yep.
Said that.
And they're going to be walking at the same time. Yep.
Yes.
Okay. And then, Ariam,
Yeah.
you put it in like math terms. What did you say in math terms?
I don't know.
They're all solutions or infinite solutions.
Yeah.
It doesn't matter what number you put in there, the cups, they're always going to be the same height. So infinitely many solutions. This is on your blue paper if you want to write a couple things down around it. If you are kind of shaky on that, you might want to write some of this down.
Which one is it?
The number of solutions for systems and for linear equations and linear systems, towards the bottom. Yes, determine the number of solutions, one, none, or infinite. So, no solutions means the lines are parallel, the same slope. Do you want to write it down, Jean? On this paper, because you can use this paper on your test. Why didn't you write this down? Because you should write it down too.
Oh, wait, we just saw our text.
That
was
said
the
that, like,
joke, you guys.
You really have a bad sense of humor. That's
I really do have a bad.
Would not be.
Okay. So, one solution is if they cross, right? If you look at a graph and they cross, there's 1 point. That means there's one solution. If you look at a graph and there's 2 lines and they're parallel, that means there's no solutions. And if they're right on top of each other, that means they have the same solution.
So, parallel? No. I don't know how to spell parallel. You know?
P-A.
I always forget too, so I just put these 2 little lines, and that means parallel.
Yeah, I spelled it P-A-R-A-R.
I don't care how you spelled it.
Okay, well, I think that's.
Okay,
I mean, that is rude to.
how do we feel about this?
all
Yes?
Culture.
We feel good about this? Right, this idea right here. Parallel solutions, parallel is no solutions. Like, give me a thumbs up or a thumbs down if that makes sense. Do you want to work with me and I'll write it? Okay, good. You have very nice handwriting for that being your wrong hand. Okay. What? That?
Outlook.com.
How did that happen?
Your soft slash.
Okay.
New Windows update.
It's hard. I think it's
So let's go to lesson 13. Unit 4, lesson 13, that new paper that I gave you, the white new paper. Unit 13. Okay. Class. Okay, I'm going to give you about 2 minutes. True or false? The first one, 2 lines, true or false. There's one on the next page, there's 5 problems. There's 5 problems to do true or false.
solution to 8 what?
Oh, you're gonna do it later.
Are we in this one?
Okay, so in the packet I just gave you, on the packet I just gave you, there's 5 true or false questions.
Or it says 2.
Is 2, let's make it true. So, okay, so let's talk about number 1, if we need a little bit of refresher here. Okay. Use the lines to decide whether each statement is true or false. Be prepared to explain your reasoning using the lines. A solution to the line, or to the equation, y equals negative x plus 10 is 2. If you put 2 in for x, are both sides equal to each other?
Yeah.
If you put 2 in, it's going to say 8 equals negative 2 plus 10. Does 8 equal negative 2 plus 10?
Yeah.
Yes. So that one's true.
So, when they said a solution to negative x plus 10, are you putting 8 in for negative x?
And for the 2x. Yep.
Okay, so we need to use okay.
So you're going to check. You're going to check all of these. If there's more than one x, then you put the number in for both x's.
And then add 4.
Mm-hmm.
I could add negative x plus 10 to it.
Okay, well,
Which
we're going to use x equals 8. So negative
So
8
we have
plus 10
8
is
for
2.
x.
2 times
Or is
8
it
is
not?
16.
Yeah, it's a
16
weird
plus 4.
sentence.
How did you get true for this? This is saying a solution to the equation 2 equals 2x plus 4 is 8. So you're going to take would be x. Mm-hmm. So definitely false. So for this one, I'm going to take 8 and put it in for x and see if it's true.
What is it? I don't understand number 5.
Yeah, 1 through 5, there's one in the back. There are no values of x and y that make those two things true. Give me an example.
For that
True or false, there is no solution that makes them true. Yeah. That was 6. So then I just like, oh no, it says find the solution to yes. Oh, no, that's
71 is 8 power.
That's false.
That was the question, like, is the statement, then.
Yes, so the true false.
Hey, that's
Negative 8 plus 10 is negative 2. I mean, it's negative 2 plus 8 is, yes, that's what it's true. I'm kind of worried about myself. My brain is like, 2 times 8. 8 plus 4. 12. Oh, no. 2, okay, 2 times 2. Yes, that's true. I saw what you did. What's up, Brayden?
So you just see whatever number it is and you put it for x.
Mm-hmm.
It's honestly
This is a true or false statement. There are no values of x and y that make that equation and that equation true at the same time. You can, it is false.
What? That's true.
Look at the graph.
Look at it, Logan.
Wait, yeah, but that's the same question. Yes.
No, it's not.
I mean, yes, kind of. But they're asking these two, is there one for both the x and the y?
Oh, you're back.
Okay, I'm gonna give you guys another minute or so.
Oh, you make that.
Oh, I am such a horrible person.
And 16 plus 4.
Miss Cummings.
No, but it's not like it's all of my first.
Okay, how do we feel about this? Number one, is number one true or false? Number two, true. Logan, please turn around. Number two is false. Number three is false. If you put 8, Luke, did you do these problems?
No.
Like how everybody always does.
Physical.
Like physically can't.
This one,
Okay, what about number 3? False. 3 is false, number 4 is true, and number 5 is true.
That was false.
Oh, sorry, 5 is false because there is a solution. You can find that solution on the graph.
Yeah. I didn't see the no.
Okay. I want you to find a neighbor near you. So we're not going to go across the room and find a friend. Find a neighbor near you and do number 13.2 matching A, B, and C. Which one of those graphs go with this system? Okay. So these are called systems of equations. The two equations match A, B, uppercase A, B, and C with lowercase A, B, and C. You can work with the partner. What do you mean?
I can't find it.
Where's the paper you were just on? Where's the page you were just on? There?
Yeah.
That's what we just finished.
Oh,
Okay,
okay.
and so then like right under what we just did is the next
The
one.
thing that says 13.
So did you want me to do this instead of that?
I know it's are a source of
I like the way I like that idea.
That's all.
Yes, we're supposed to work together.
Yeah, that's Logan. So, this one is really not. But it's so funny.
you're relatively.
30-minute video. She's gonna run out of storage soon. It's gonna be like, you gotta start deleting some names.
That's the time that we do equations. Oh, I have no idea. I don't know
You're probably one of the only celebrities who don't have Probably.
Yes.
No, I remember showing this big list. You have too many celebrity questions. I have one.
Let's go, no, you don't have to hold the whole glass.
One celebrity question
Don't
is
get
15.
too attached to any of the characters because they
Luke's like looking at me,
This is why.
I'll see you don't look at
Hey, it's lit. Get your eyes off those things.
Consider
What
this,
thing?
right? That would be nice.
Okay, so you should be about done.
I enjoyed it.
Okay. Do you have any ideas?
It's really easy.
Okay.
Yeah.
One thing you can do, this is how I would have tackled it, and I heard Ariam saying the same thing.
Good job, Oliver.
We know, because we know how to graph these equations, y equals mx plus b, we know where the starting point is for each of these equations. So for example, lowercase a has the first equation that says y equals 3x plus 5. We know the slope is positive, and we know it's going to start at 5. So we're gonna look for one of the graphs that has starting point at 5. You can work with Sierra or James. You guys wanna work together with that? Okay, yep, good. So the first one is A.
It's really easy.
Okay. How do we feel about this? A, the first one is A, because we can see that the, that one of them starts at 5 and one starts at 20. The next one, B, the slopes are both positive, and one of them starts at -10 and one of them starts at -1. Yeah. You can also tell A is the only one that has one positive and one negative slope, so that's another way you can tell that A is matched with A. Is that what you see? Yep. So A, B, C, and CB. Give me a thumbs up if you feel good about that. Okay. Okay. So then I want you to go to the lesson summary. You don't have to. Okay.
And that is on the flip side, right?
On page 4. Sometimes we can look at the equations and we don't have to graph it to see if if it has a solution, right? If they have different slopes, they have different y-intercepts, we can tell those things. So for example, if you're looking at this one here, y equals 2x plus 6 and y equals -3x minus 4, we can set them equal to each other and tell that the x's are not going to cancel out, and that they so that means that there is at least one solution if the x's don't cancel, and then if the y-intercepts don't cancel, then there is only one. But if the y-intercepts cancel out, then there is also infinitely many solutions. Does that make sense? We'll do some practice problems.
Makes a lot of sense.
I have a question.
Yes.
For like the example that's used right here.
Mm-hmm.
So you start at 6 to graph it.
Okay.
You start at 6 and then you just do 2 over 1. If there's
Yes.
not a fraction.
Mm-hmm. Yep. So let's work through this a little bit more. If we have one equation is 2x plus 6 and one equation is -3x minus 4, we can find out what x is by setting them equal to each other. Okay, I want you to go ahead, work with me because we're running a little bit short on time.
I'm with it.
I want you to write it down.
Oh, yeah. Oh, it's already written down for us.
Yeah, language parts.
Okay, fair enough. Okay. We're going to get rid of the numbers first. I say I want to add the 4. So we have 2x plus 2 equals -3x.
2x plus 2? No, 2x plus 10.
Jeez Louise. Okay, so now we have to combine the x's.
Yeah.
This 10 is over here, so I'm going to go ahead and get rid of the x. Why did I subtract?
Because it's already added.
It's negative. This one is positive. So we have 10 equals -5x. And this is on your paper, but we're just going to work along together. So -2 equals x. But we don't know what the y is, do we? How can we find the y?
We graph it and see where they intersect.
We can do that. We could also just take this 2x, this -2 equals x, and plug it in. So we'd have 2 times -2 plus 6. What's 2 times negative 2? Negative 4 plus 6, 2. So this is y.
Wait, where's the y equation?
We can do either one. Negative 3 times 2 is negative 6. Minus 4 is negative.
It would be negative 2. Negative 3 times negative 2.
Negative 3 times negative 2 is negative 6.
Wait, no, it's negative 2, right? Because negative 2x.
Oh, yeah. Yes. Negative 3. This 2 should be negative already. 6 minus 4 is 2. So it doesn't matter which equation you use. Your x is negative 2 and your y is positive 2, so now you have the ordered pair. Yeah?
Yep.
Okay. Your homework tonight is to do the lesson 13 practice problems.
All of them?
Yes.
This is coming. Again, guys.
Good. Hold on. For you guys, class. For numbers 3 and 4, this is probably the easiest way to do it. I'd like for you to practice this way. If you're stuck, you can look online and get the video. I would say you should be looking around 30 minutes in for this part. Okay.